Good morning, students. I hope you are all well. Okay, so we are continuing with the same exercise, that is, uh, second exercise of chapter triangle, chapter 7. This is exercise 7.2. I gave, I did question number 1, 2, and 3 for you. I gave question number 4 to be done by yourself. Okay, so now we are moving on to question number 5. I have already explained how to do question number 4. Moving on to question number 5, let us write down once again what is given to us and what is to be proved. What is given to us is triangle ABC and triangle DBC are two isosceles triangles on the same base. Okay, BC. So what we have is triangle ABC is an isosceles triangle. That means AB and AC are equal. In triangle ABC, you have AB and AC as equal. In the same manner, in triangle BCD, in this below lower triangle, you have BD and CD as equal. Okay. Next, you have to prove. You need to prove that angle ABD, angle ABD is equal to angle ACD. Angle ABD is this complete angle, and angle ACD is this complete angle. Okay, so there are two means by which you can prove that these two angles are equal. One way is to use the theorem that we have learned in this exercise. How so? We will say that in triangle ABC, this side and this side is equal. Therefore, these two angles are also equal. If this angle is x, this angle will also be x. Okay. Similarly, in triangle BDC, since it is an isosceles triangle, so both of these angles will be equal. Now, sum of this angle and this angle is x plus y, as well as sum of angle ACB and DCB is also x plus y. Since sum of both the angles are equal, angle should be equal. Okay. In this manner, we can prove using just only theorem that both of these angles are equal. Okay. Secondly, you can also do this one by using of congruency. How do we do that using congruency rule? You will draw a construction, you will join line AD. After joining line AD, you will get two triangles, triangle ADB and triangle ADC. In these two triangles, you have one side as equal, one side, this side as equal as well, and this side as common. So by doing that, you can get to use SSS congruency. Since SSS concurrency is not discussed till now, SSS concurrency comes in next exercise. So I will discuss SSS concurrency next exercise. Okay. So we will do with the theorem that we know till now. We will complete this question using the theorems that we are aware of till now. Okay. That is theorem number 7 point. Okay. So let us do the solution. For its proof, what will we say that in triangle ABC, since uh, AB is equals to AC, which is given to us, so we can say that angle ABC is equals to angle AC. Why so? By using theorem 7.2. Theorem 7.2 states to us that for any triangle, the angles opposite to equal sides of a triangle are also equal. Let me write down the theorem for you. Okay, so we will get our first equation using this theorem 7.2, and similarly we will use theorem 7.2 in next triangle again. Let's write down similarly in triangle A, sorry, not A, in triangle DBC, since BD is equals to CD, that is given to us. So we will have angle DBC is equals to angle DC. Why so? Once again, theorem 7 point. This will be our second equation. By adding equation 1 and 2, we are adding equation 1 and 2. So on adding that, we will get angle ABC plus angle BBC should be equal to angle ACB plus angle DC. Okay, so sum of these two will be like angle ABD. This is angle ABC plus angle DBC will be equal to angle ABD. And similarly, that will be angle AC. Both the angles are equal. You can also use congruency here, but the congruency that can be used here has not been discussed by me till now. Okay, that is why I am using this method. Next is question number 6. Question number 6 is triangle ABC is an isosceles triangle in which AB and AC are equal. So let us start with what is given to us. In triangle ABC, this is triangle ABC, A, B, C. In triangle, I've written ADC. This is A, B, C. In this triangle ABC, you are given that length AB and AC are equal. And secondly, you are also given that AD length, this length AD and AB are also equal. So first of all, let us observe something. We have triangle ABC as isosceles triangle because AB and AC are equal. Similarly, for triangle ADC will also be an isosceles triangle because AB and AC are equal. That means AD and AC should also be equal. Suppose this length is 7 centimeter. You are given that AD is equals to 7 centimeter and AC is also 7 centimeter. That means value of AD and AC is also equal. That means triangle ADC should also be an isosceles triangle. Okay. So before starting the question, it is an observation that you should have. Okay. Now, what do we need to prove? We need to prove that angle BCD is a right angle. Angle BCD, that is angle C, is a right angle. Angle BCD is a right angle. Right angle is of 90 degrees. We need to prove that angle BCD is a right angle. So how should we prove it? Once again, we are going to use theorem 7.2. So first of all, in triangle A, B, C, in triangle ABC, since AB and AC lengths are equal, so angle opposite to equal sides are also equal. Angle ABC is equals to angle ACB is equals to X. We are letting that both of these angles are equals to X. So this angle is x, this angle is also x. Okay. Now moving on, in triangle ACD. In triangle ACD, similarly, okay, one more thing, you have to write down theorem. We have used theorem 7.2 here. Now similarly, in triangle ADC, since AD is equals to AB and AB is equals to AC, that means AD and AC should also be equal. So by theorem 7.2, angles, what are the angles? Angle ACD should be equal to angle ABC, and I like that both the angles are equal to y. Okay. Now see, in triangle DBC, we already know that for any triangle, 1 minute, I've said this angle is y as well as this angle is y. Now for triangle DBC, do you know what is sum of all the interior angles of a triangle? Yes, correct, 180 degree. So for triangle DBC, sum of all these three angles should be equal to 180 degrees. What I'm saying is angle B plus angle C plus angle D should all be equal to 180. Now let's see the diagram. Angle B, we let that angle B is equal to x. Angle C is sum of x and y, x plus y. And angle D was determined as y is equals to 180 degree. We will simplify this expression. This will be 2x plus 2y is equals to 180 degree. And taking 2 as a common factor, sorry, 2 x plus y is equals to 180 degree. Now this 2 goes there to the division and value of x plus y is 90. Okay. Now in the diagram you can see that angle C, or you can say angle BCD, is equals to x plus y, and value of x plus y we determined as 90 degree. Hence angle BCD is a right angle. Angle BCD is a right angle. Okay. I hope you get this. Now next is question number 7. There is no diagram given with question number 7. Okay. So we have to draw the diagram by ourselves. First of all, let us draw a triangle diagram. We are given that ABC is a right angle triangle with angle A as 90 degree. So we have a right angle triangle. This will be the height, this will be the base, and somewhat here. Let us name it. This point is A, that is 90 degree. This point is, let's say, C. This point becomes, we are given that in this triangle AB length and AC length are both equal. We have to determine the values of angle B and angle C. Okay, so let us write down what is given to us. In triangle ABC, for triangle ABC we are given two things, angle A as 90 degree and angle B, sorry, not angle B, and length AB and AC are both equal. Next, let's see what we have to prove. Actually, not prove, we have to find out something. What we need to find out is values of angle B and angle C. We need to determine the values of angle B and angle C. Okay. So let us start with that. See, in this triangle, in triangle ABC, what we have in triangle ABC, sum of all the interior angles is 180 degree. Okay, we will come to that. But first of all, let us see, since AB and AC are of equal length, so by theorem 7.2, we can say that angles opposite to them are also equal. That means angle B and angle C are also equal. Let them both be equal to x. Now, by angle sum property of triangle, okay, what is angle sum property? Sum of all three angles of a triangle is 180 degree. Angle A plus angle B plus angle C should all be summed to 180 degree. Now, value of angle A is given to us 90 degree, and we have let that B and C are both equal to x. Angle B and angle C are both equal to x. So this will be 2x is equals to 180 degree minus 90 degree. This is 2, okay. So that means value of x should be equal to 90 degree upon 2, that is 45 degree. Okay, that means angle B and angle C are both equal to 45 degree. Okay, so this is an important thing for you to remember. If you have a right angle isosceles triangle, that means other two angles of the triangle are, or you can say acute angles of that triangle are both of 45 degree. For a right angle isosceles triangle, its acute angles are both 45 degree. Okay, now this is question number 8. That is the last question for today. Okay. Once again, no figure is given to us. We will draw the figure by ourselves. We are given that show that angles of an equilateral triangle are 60 degree each. So first of all, let me draw an equilateral triangle for you. This is an equilateral triangle, triangle A, B, C. Okay, so for an equilateral triangle ABC, we have to prove that each angle is equal to 60 degree. Okay, so what is given to us? In triangle ABC, AB sides is equals to BC side is equals to CA side. All three sides are equal. We need to prove that angle A is equals to angle B is equals to angle C is equals to 60 degree. We need to prove this. We already know this thing happens, but now we have to prove it. So first of all, see, in triangle ABC, since these two sides are equal, AB is equals to length BC. That means angle opposite to them by theorem 7.2, angle opposite to them will also be equal. So AB, angle opposite to side AB is angle C, and angle opposite to side BC is angle A. Angle A and angle C are both equal, and I let that both are equal to x. Similarly, we know that BC and CA are equal. BC and CA are equal. So once again, by theorem 7.2, angle opposite to BC is angle A, and angle opposite to AC is angle B. Now we already know that value of angle A is x, so value of angle B should also be equal to x. Now it is quite easy to do. By angle sum property, by angle sum property of triangle, what will happen is angle A plus angle B plus angle C should all be equal to 180 degree. Now values of angle A, angle B and angle C are all three. X is equals to 180 degree. That means 3x is equals to 180 degree, and you can simplify it to get the value of x as 60 degree. Okay, that means angle A plus, sorry, angle A, which was equals to angle B, which was equals to angle C, which were then again all equal to angle X, are all equal and are of value 60 degree. Okay, so once again, let me remind you, all the questions that we are discussing are to be done in your homework copy. Let me rephrase it. All the questions of your geometry part of your book, of your NCRT, are to be done in your homework copy. Okay. Shortly, in few days, I will start with some extra questions for you as well. So those extra questions are not to be done in your homework copy. You can do them in your classroom copy as well. Okay. All the theory, the theorems, the proof of the theorems that we discuss are to be done in your classroom copy. Only the questions as well as the examples of your NCRT are to be done in your homework. Please don't get confused again and again. Okay. So thank you for your time. Have a nice day.